Hi everyone, my name is NURAL Cokcetin and I'm a research scientist, and welcome to Cafe Classroom. So today we'll be talking about my areas of expertise, and I specialise in microbiology, and specifically my research focuses on the medicinal uses of honey. So I first got interested in this field since I learnt about bacteria for the first time at school. I was fascinated by how these invisible little creatures could have such a big impact on our health and the environment. So we now appreciate that bacteria are everywhere. They live in huge numbers in the soil, in the water, in the air, on our skin, and even inside of us. Most bacteria are actually good for us and essential to our survival. And it's just as well because they grossly outnumber us. But it's those few nasty bacteria, the ones that can cause life-threatening infections and disease, that really piqued my curiosity. And I loved learning about the worst ones of all, the superbugs. These superbugs are bacteria that have evolved to protect themselves against the attack of antibiotic drugs, the same drugs that we've designed to kill them. These superbugs are also responsible for the global crisis of antibiotic resistance that we're currently facing. Antibiotic resistance is one of the biggest threats to human health today, and it doesn't discriminate. It can affect anyone of any age living in any country. And already we're seeing cases of people dying from infections caused by these superbugs, where we have no antibiotics left to treat them. So before long, lots of common everyday events like a visit to the dentist or routine surgery, which can sometimes result in a common infection, could very quickly turn into deadly threats. Traditionally, antibiotics were found in nature, so now we're looking back to nature to find new ones that work, and this is where honey might be able to help. So honey has been used as a medicine throughout the history of the human race, and we've got records of its importance and its use, documented in rock paintings and carvings, and sacred and medical texts from lots of ancient cultures around the world. Honey has been used to treat a wide range of ailments, from eye and throat infections to diseases of the gut. But its most common and most effective use is as a topical application to treat wounds, burns, ulcers, and skin infections. Now, the reason for its continued medicinal use is no doubt because honey has potent, broad-spectrum antibacterial activity, although it's unlikely that the ancient cultures would have used that exact wording, since we didn't learn about the invisible world of bacteria until much later. An important point to remember is that honeys are not all created equal. Many of the ancient cultures that used honey would prescribe certain honeys from certain locations, seasons, or flowers for certain medical conditions. So, perhaps without knowing, they were choosing the activity of the honey based on the floral source. And a common misconception today is that honey is just a standard product. But actually it's incredibly complex. It's got over 200 components. And some of these ingredients include things like simple and complex sugars, vitamins, minerals, and other substances, all of which can vary depending on which flowers the bees visit to collect the nectar that they then turn into honey. So in the same way that different honeys can look and taste very different, they can also have very different medicinal properties. So it's really important to find the best ones for the most appropriate use. So this antibacterial activity of honey comes from multiple different factors. First, we know that honey is very high in sugar, and this can dehydrate or dry out bacteria. Honey also has a low pH, which means that it's acidic, and most bacteria can't tolerate this. Now, these two things are common for all types of honey, including the ones that we have at home in our pantries. But they only make up a very small amount of the overall activity that we see. So while these pantry honeys are great for spreading on toast, their activity probably isn't quite strong enough to clear an infection. In some honeys with very potent activity, this is usually because of the production of a chemical called hydrogen peroxide. Now, this happens via an enzyme that the bees add to the honey while they're making it. Hydrogen peroxide is toxic to bacteria, and this level of activity can vary hugely from one honey type to another. And finally, there are some very rare honeys with a special type of activity that we don't see in any other type of honey. Now, this activity is linked to a particular chemical that comes straight from the floral source. The most famous example is Manuka honey, which is derived from the Manuka plant. And this Manuka honey is the most commonly used medical grade honey available to us. So one of the most exciting things about honey is that despite its use for thousands of years, bacteria have never learned to become resistant to its killing effects. One of the first things that we tried in the lab was to create these honey-resistant superbugs, but all of our attempts were unsuccessful, even though we could get antibiotic-resistant superbugs within just a couple of weeks. We also wanted to see if we could use honey against lots of different types of superbugs. So some of the examples of things that we've looked at are golden staph, which commonly infects wounds, Pseudomonas, which is a real problem for burns patients, and certain types of Streptococcus, which is known as the flesh-eating bacteria. What we and many other researchers have found is that honey works against a whole suite of superbugs, including ones that can resist or fight off multiple different drugs. So now we're working on trying to understand what it is about different honeys that makes them so potent against bacteria and why bacteria don't become resistant to it, the way that they become resistant to antibiotics. So the way antibiotics work is generally they'll target one specific thing in bacteria. So here we've got a bacterial cell, and an antibiotic might work by targeting this protective cell wall around the outside of the bacteria. But bacteria are very clever. They can very quickly evolve to protect themselves against this attack. So essentially what they do is reinforce this point of attack so that that drug doesn't work against them anymore. What we see with honey is that all of those different components work together and target multiple different sites of bacteria at the same time. So not only are you attacking that protective cell wall, but you're also attacking this tail that helps bacteria to move, their ability to make and repair their DNA, and also their ability to communicate with other bacteria. So altogether, this overwhelms the bacterial cell so that it can't fight off or protect against all of these attacks at the same time. Essentially, what we've got is honey as a super drug that we can use to fight against super bugs. That's it.
Hi, I'm Ravi Prasad from Parliament on King. Aside from the cafe, we also have a social enterprise catering business. We work exclusively with members of the asylum seeker and refugee community. We make food from their homeland the way they make it at home. If you'd like to support the work we do with the asylum seeker and refugee community, just click the link below, which you'll see in the comments. Thanks for supporting the work we do.